pretty sure I'll get exactly the same error you were
I
getting.
have the equals.
You do have the equal
I
equals?
had that. I had the code exactly as you had it on the screen.
Oh, so let me put it back. You had it like this? I don't think so.
Okay, I see. I had the close parentheses.
Yeah.
Okay, but I had the equals after that.
Yeah, that's why. Because inside the condition, see this part here, this part, because it's a branching statement, it's an if condition.
Right.
If,
You need
so,
something.
yeah, this needs to be Boolean. This needs to be true or false.
Got it.
It's a string. Oh, if it's an integer, yeah, I would. Yeah, if the user input is an integer, I would not do a test like this in C++, right? Because in C, you can use an integer. In very rare conditions, situations, you can actually use an integer as a Boolean. But C++ gives you syntactic sugar. Strictly speaking, it is not a true Boolean. Okay, in C++, the true and false values are not true Booleans. They're just names that are slapped on to zero and non-zero values for the programmer. Under the covers, they're still integers. But in certain languages, you have true Booleans, right? So you actually have one bit that represents a true value and a false value. But C++ is just syntactic sugar. It just codes it. It's like, well, to make your program readable, say true and false, but internally out. And so what some programmers do, and they will leverage C-style features in C++, and they would do things like this. Let me put this back. Okay, they would do things like this. While n or minus n. Oops. Okay. Now that's fine. Because here. This is what Virginia was talking about. You said, this needs to be a Boolean, not a condition. Well, it needs to be a condition, which returns a Boolean, not an integer, right? But an integer will also work in C++. Why does it work? It works because C++ inherits from C. Everything is because it's C compatible, right? And every C++ program is a valid C program. Oh no, the other way around. Every C program is a valid C++ program, right? So, in order to provide that level of backward compatibility, it had to inherit the true-false Booleans from C, which means that if you have an integer or a numeric value that is 0, it's interpreted as false. Anything that's non-zero is interpreted as true in C, and it also works in C++. And unfortunately, even though computationally it is not more efficient these days, right? It is not more efficient to say, this rather than while minus n is greater than 0, right? That is a proper condition because I'm comparing a number to another number that has to be true or false. It's a proper condition. Whereas if I did this, it's an implicit condition. Because an implicit condition only works in C++ and Java. It's languages that know that, right? And it's better not to do that. Just do the proper condition so that it reads well, it's equally efficient, and so say things like this. Does that make sense? Yeah? All right. You good? Are you guys working on Quests or this ELIZA code in class?
Quest.
You're all working on Quest? So you don't even need to come to class then. So you all right. But you can work on your Quest or knock yourself out at home as much as you want. But in class, take advantage of these things, right? Work on class code. Come up with your own programs. Get your friends to implement it. Right? Classmates implement it. And so, like ELIZA, take that to the next level. I've given you a basic ELIZA. Take that to the next level. Break up the words. Do some interesting things, right? So that you can do in class. In Quest, you can do it at home.
What does it mean if there's a control reaching the end of a non-void function?
Yeah, okay. So again, you're working on the Quest? Yeah, so, okay. So try and not work on the Quest in class, okay? It'll be more exciting, I told you, I promise you, right? Work on others. We'll have a lot of other stuff, interesting, exciting stuff to work on in class, right? It's not like I'm not giving you interesting things to work on in class. And most of the time I'm talking, right? So just put your computers and listen to me. But yeah, keep the Quests for later, after dinner, enjoy working on the Quest with a glass of wine in your hand. All right? Okay, all right. So Christopher says, he's got a function, and the compiler complains that, hey, it's a void function, it's returning a value, or it's a non-void function, and it is not returning a value. Those are the two conditions where the compiler complains. So suppose I have a function here, let's say here. So let's say int, return, and int, okay? And then I say print here instead, okay? Or cout, return, okay, well, make that more real, okay? Return, add 5, okay, let's say add 5, okay? Get, add 5, what's a good name for it? Get 5 more. I don't know, add 5 too. All right. You spend 90% of your time just coming up with good names, right? And 10% of the time actually coding. So add 5. I'm just going to call it add 5 right now, okay? And then I'm going to say n plus 5 here, okay? Okay, so if I try and compile this, let's do another one, which does not. Okay, and then I'm going to say print 5, and print add 5, okay? And here I'm going to say return n plus 5. Okay, so I got these mixed up essentially, right? So I got two functions. One of them is supposed to print and not return. Yeah? The other one is supposed to return and not print. Now, but I got the names, I got the signatures mixed up. I'm asking the function that prints to return a value. And so if I try and compile this, I'll get 2 times the error that Christopher got, right? It'll tell me, hey, you got a function that is supposed to return an integer, it's not returning an integer. And this, by the way, the signature is wrong. This should be void, okay? Because it's not returning anything. It's only when you return something, you say I'm returning an integer. So it's void, I'm not returning anything, okay? So now the compiler, because it has my back, it's going to tell me, hey, this function is supposed to return something, it's not returning. Okay, so let's try and compile this. G++-O, basic ELIZA. Oh, you don't need the output file, so we'll just do a.out here. Basic ELIZA.c.
I think you switched the function.
I did?
Yeah. Because the print you did a void, but for the int.
Oh, thank you so much. Yeah. That should return, and this should be void.
You just automatically assign the correct
Yeah.
returns for your function.
Yeah. Thank you for that, Virginia. Okay, so let's compile this, and you'll see that I'll get. Oh, what happened? Where's my compilation line? Oh, here. Okay. All right. So this is what error you got. Okay.
But like if I do a return 0 because it's expecting a return, then it doesn't yell at me anymore.
Yeah, but this is wrong.
That's wrong though.
Yeah, but it's not gonna debug your logic for you.
It's not.
Right? Yeah, the compiler will debug your syntax for you, but not your logic. Right? That's why debugging logic errors is when it actually gets interesting, because that's when you're doing the debugging. Syntactic debugging, 90% of the job is done by the compiler and other things for you. So it's not as exciting. So get past the syntactical errors first, and then you get to the interesting part, where you're saying, that's the really interesting part, right? Because you have a logic in you have the logic in your head, you know what needs to get done, it's not getting done, then you have a puzzle. As humans, we're always have this, fascination with puzzles. We always want to solve puzzles because we have an expectation. That's why science is so interesting, right? Science is basically one large puzzle, because the world around us, things happen, and we're curious to say, why does it happen this way? Why does it happen that way? Each one of those is a little puzzle. And that's why scientists are basically, puzzle creatures. They're trying to solve puzzles all the time. And it's a fun thing, right? If that's what you had to do, if someone said, you got to do something all your life, you pick one of these, I'd say, all right, if I got to do something all my life, I'd basically be a puzzle solver, right? Because you can keep your mind occupied and have fun. Oh my gosh, Marnie's waiting. Okay, all right, thank you very much for